In the first chapter, we made a very brief introduction to the background of Matlab or other mathematical languages. And in this part, we will first address why we have to study computer mathematics languages and what are they. And then I will give you a brief talk on analytical solutions and numerical solutions to mathematical problems. And then we make a very brief overview to mathematical software packages. So let's start the first one. There are many ways to use computers to solve mathematical problems. If you are trying to solve a certain problem, you can use different languages. For instance, you can use C languages. And if you want to find the eigenvalue of a matrix, you have to find a proper package, and then link the package, and then you can solve the problem. On this part, we call it using numerical method and writing code from low level part. And this will cost you very much time to do so. And if you are using a high-level mathematical language, what you need to do is simply use high-level commands. And for instance, if you use Matlab, you can get the eigenvalues of the matrix in a single command. You can get the eigenvalues. So we have these two kinds of computer usage. One is by low-level programming. The other one is by high-level programming. Also, if you want to solve a mathematical problem, what you used to do is, when you learn the calculus, what you used to do is to derive the result by hand. For instance, if you want to get a limitation of a certain function, what you need to do is to follow some kind of strategy and get the solution by hand. But if you are using Matlab or this kind of computer languages, you will find that the problem becomes very simple. I shall give you some examples first. In college mathematics course, you learned how to find the derivative of a given function. For instance, if you have a function like this, and you are expected to find the first order derivative to it, what you need to do is to use the derivation formula for, you can find the first order derivative first, then take another derivative to it, and so on, until you find the fourth order derivative, and you can imagine how complicated it will be. And with the use of Matlab, what you are expected to do is something like this. I will go to the details later on, just to give you a brief talk about it. First, you have to declare that X is a symbolic variable, which is quite different from the one you used before. You used the numerical variable. Here we can use symbolic variable, first declare it, and then define the function in Matlab command. And then you can use the simple command to find the first order derivative. It is quite easy, so you can click the icons here and go to Matlab. And paste it here. And then you can get the result. And sometimes you will use the command for the first time. It may take some time to compile it. So this is the result, quite a long result actually. Imagine that if you are trying to do this kind of thing by hand, it may take you quite a long time. And fortunately, if you get the result by hand, you cannot rely on it, you cannot trust it very much, because a very slight error in the derivation may give you a wrong answer. But with a proven computer language, you can get reliable results immediately, and you can use the command preview to show it in a better way. Something like this. Quite complicated. So use a computer, you can leave the tedious work to computers. So what you need to do is to use a Matlab recognizable command. and then you can get the result. You do not have to worry how to solve it. Just leave the work to Matlab environment. And this is another example. You can immediately recognize what this command means. It will take 100 order derivative to a function. And the other two functions, one is to start the stopwatch and run the command and then read the stopwatch. 100 order derivative of a given function. And you can see you can do it in less than 1 second. So this is my example. Consider another example. Consider a polynomial equation. It is well known that through the Abel-Rosny theorem, it is stated that there is no general solution to a polynomial equal 5 or higher. So what you need to do normally is to use a numerical method to find the solution to a polynomial equation. But now let's consider a 6th degree polynomial equation like this. If you are doing it in double precision or numerical method, what you need to do is something like this. This is a Matlab command. You can also write C code to do so. I'll explain it later. In this command, we use P to denote a vector which contains all the coefficients of the polynomial. And then we just use root command to find the root of the polynomial. And that's all we need. However, there are some errors in this result. Because we use the double precision numerical algorithm, we cannot get exact results for certain polynomials, especially for the ones with repeated eigenvalues. So there are some errors. You will substitute it back to the original polynomial, and this is the error you are expected to get. So pure numerical computation may cause some errors. And in the engineering point of view, it is quite acceptable. You can see the error is very small, so we can say that they are the solutions to the original problem. And if you are using a symbolic solution to such a problem, what you need to do is to convert it first to a symbolic variable, and then we use solve command to find all the eigenvalues or the roots of the polynomial. And we see that all the roots are the same. They are repeated roots. And these results are not possible by numerical method. So it is only available by symbolic method. And Matlab is capable of solving this kind of things. Let's consider the third example. The determinant of a matrix